All right, looks like the gang's all here, so let's go ahead and introduce our panel for tonight. I'd like to introduce Jeff Miller from Durham, North Carolina. We've got Keith Perkins from Oklahoma, Rich Falco from Florida. Hi, Rich. Stay safe down there. And I'm Randy Briggs. I manage the CTI Research and Development Center, but I'm speaking to you from the wilds of South Dakota. That's kind of a long story.
All right, so it's the domestic keys and immobilizer system class. Our mission at CTI is to provide the best training we can. We always talk about that. The important part is, not how many parts we can sell off this, because we don't really talk about selling anything. We're not here to sell you anything, just short of hopefully the ability to make more out of your bay. So keep that in mind that anything we teach you is for the benefit of you as a technician. So please try to utilize that as quickly as possible. I can tell you just from my experience, I like to always put out there, the more often I can use a skill that I learn, the quicker I can learn it or use it after I learn it, the better off I am with it. I tend to lose a lot of that information if I don't use it quickly. So please put this to good use. So this class is as short as what it is. We're going to try to cover as much as we can. So we're going to explore the general operation of these immobilizer systems. And when I say general, I mean general. We can't get too specific because we could pick one particular year, make, model and talk for an hour on its immobilizer system alone. We're going to try to review some implementation from the OEs of that system, again, in the general form. So how well that manufacturer can implement that across multiple different things is going to be a big part of it as well. We're going to discuss some current service challenges when it comes to this. A lot of it's tooling. Most of it is understanding the system. So once you've got these first two down, really walking yourself through an immobilizer issue can become very easy. And sometimes it does take a little bit of tooling investment. We know that as technicians, but it can be minimal to get yourself started. So some terminology we need to talk about first. Transponder, chip, pill, those are all things that are pretty much the same component. They're the transponder unit inside of the key, and we're going to talk about that here in a moment. Programming, registering, coding, learning in, or teaching in, those are all the same, different words for the same process for getting a key to work for a vehicle. You hear programming a lot, and usually that's actually incorrect. Usually we're registering a key to a vehicle. But in newer vehicles, there is some actual programming going on. We are transferring data to the key on some newer vehicles. Ring, antenna, oscillator, or receiver, those are all names for the same component. The manufacturers each have their own too. Some call it a VTD module or a PATS module or a theft module. But that's the ring that goes around the lock cylinder that usually reads the key. And again, we're going to talk more about each of these components. Then there's smart key, prox key, advanced keyless entry key. Those are all different names for keys for a push button start vehicle. Handshake, parameter reset, key code erase, and initialization. Those are all words for performing some kind of function globally on the network to let it know that we've either entered a new module onto the network, or we're initializing a new system where we just want to erase all the codes or erase all the keys. Usually those are all the same functions. A lot of these are some forward names, but we're going to kind of break down what we mean when we talk about those procedures and why they have to happen. So a PIN code is something that's on some manufacturers is used to access immobilizer functions. It's usually synonymous with the vehicle's VIN number, or is specifically assigned to that one VIN and usually isn't shared with any of the vehicles. LSID is your locksmith identification, which is required to do a lot of functions for keys. And we're going to talk about NASTF and how to get one and some of the requirements. So two things that we're not really going to talk about in the class, but I'll cover real shortly, is cut code and key bitting. So a cut code on a key can be a short 3, 4, or 5-digit number that can be calculated or converted into the key bitting, which the bitting is the actual cut of the key. So across the key, if you look at all the different sections, they each have a number assigned to them. So a key bitting could be like 124422412. It could be something as simple as just 2 or 3 different of the 5 different biddings for that key, or whatever options there are. And the cut code for that could be like a 5821. Something completely unrelated, seemingly, but with either a book or a subscription-based service or calculation, that number can be changed into the actual bidding of the key. And the reason some of this terminology is in there is this is a section of a much larger class. So please just be aware that this is an all-encompassing subject. It's just kind of get your feet wet. hopefully just get you to know just enough about the system that it's not so much of a black art anymore. So let's talk about some of those components. The first one will be the transponder chip. And there's 3 versions here listed. And the one on the far left there, you can see is a little glass chip. It has a circuit board and an antenna and a couple other components in it. We're going to break that down here in a minute. The one in the center is a PCF style chip. So it's actually soldered onto a circuit board and performs communication along with doing the same functions as that one to the left. That's what you're going to see on most of the phobic style proximity keys or newer keys, is one that's soldered on a circuit board. And the one to the far right is probably the most commonly used transponder chip for a non-push button key or a non-circuit board key. And that's just a plastic version. It depends upon the manufacturer of the chip and the encryption type on what type of chip it will have. So just these are 3 common ones, not all the options, it's just the 3 most common you'll see. So the parts of this transponder are important just in understanding how it works so we can diagnose when there's a problem later. There's an IC board on there that actually does the functions, actually will communicate. It has information that's being transferred from one side to the other. It's not just a single little chip. It's actually quite a bit of information going on there. There's an antenna that has 2 purposes, and that antenna core is integral to the antenna actually working. So the antenna acts as a receiving device to both receive a magnetic field, an actual electrical induction to charge up the IC board, because there's no battery inside of this. So when the antenna ring, which we'll talk about in a minute, actually powers that antenna coil up, it receives enough energy to actually do what it's supposed to do, whether it be yell out a serial number or communicate back and forth more than one time. There may be quite a few functions happening between the key and the antenna ring. Well, that's all powered by the antenna coil, and then it's re-pushed, that information is pushed back out of that coil. So it both acts as a receiving to receive the energy to energize the transponder, and the antenna to boost that signal out so the receiving party, which is the antenna ring, can listen in on that. So let's talk about that part next, the antenna ring. So here's, from the big 3, we have a Ford PATS module on the left, we have a Chrysler Wind node in the center, and a GM VTD module on the far right there. They all 3 do the same things in essence and what they do for the Immobilizer system, but how they do it and the other things they do are all unique to them. And what it takes to replace each one of these is all completely unique to its manufacturer. But overall, the design is pretty much the same. There's another antenna coil there, and there's a circuit board. And that's the essentials of almost all of those antenna rings. So this IC board will act as the controller that communicates with the theft modules on the vehicle and communicate data. Sometimes it'll communicate just a, yeah, you're good to go. Sometimes it'll send all of the key data for another module to make that decision. There's all kinds of functions that can happen in there, but essentially that IC board powers that antenna ring to send out that secondary voltage, just like similar to an ignition coil, to actually power that transponder that's inside the key. And then at the same time, it starts to listen in for what comes back. So all that happens very quickly. And of course, there's the keys, right? That's a big part of the system. So there's all kinds of different keys here, and you can see there's a couple generations of keys there. So let's kind of break down what there are there. So of the chip style keys, and chip, of course, is in quotations there. We can start with the first key that most of us ran into that was a Immobilizer concern, and that's a VATS key for an old GM style system. I'm going to spend just a second on this one here because we're not really going to talk about this system at all for the rest of the class. It's pretty antiquated and not in a lot of vehicles anymore. I'm in the South, so we still do have quite a few of these vehicles running around. I do run into them often, but across the country, it's less likely you'll see this system at all. So this key actually has a resistor inside of it, which is not at all like the transponder chips that we just talked about. This is a literal resistor. When the key's inserted into the lock cylinder, that resistance will be read by a separate module in the vehicle called the VATS module, and it's reading that through a pair of wires that's physically connected to the lock cylinder that's physically touching the 2 ends of the resistor. As long as that resistance is the correct resistance that's programmed to the VATS module, the VATS module will send either a 30 or a 60 hertz square wave signal to the PCM. 30 hertz signal is usually on the LT1 V8 cars, and then almost every other car uses a 60 hertz square wave signal. And it's transmitted over just a single wire to the PCM. When the PCM receives that signal, that's the okay for the theft release. So that's when you'll get your injector pulse and control and everything else. And so it's a pretty simple system, but you can see how a few different locations could cause a breakdown. And that's about all we're going to talk about the VAT system, because it is uniquely different than all the rest of these transponder systems. So then onto our standard transponder chip, which again, this type of key just houses one of these transponders. It could house any one of the two non-circuit board style ones that you'll find. I have not found this regular, plastic head, no buttoned key that has a circuit board in it. All of them have just one of these two transponders we talked about. And again, that transponder doesn't house a battery. So, the plastic of these keys is important. And you'll find that some of the inferior aftermarket keys that you can add chips to, I've ran into a couple issues with some of the cheaper ones where they actually will not allow the transponder to communicate through the plastic because the plastic has some kind of different chemical makeup in it. So if you're getting into this and starting to buy, keys with a spot to put a transponder chip, make sure you buy some kind of name brand key. The more common that we see now is a phobic style or a finger operated button integrated key system. This has a transponder chip at the top that's actually soldered to the circuit board. And then the remainder of the key is actually the circuit board for the phobic or the remote entry functions. Now, those are usually, and I say usually, because under most circumstances I can think of, programmed together. So once you program the transponder, the remote becomes programmed at the same time. But that is not always the case. It's just usual. The slightly different version of this would be one for a proximity key. And you'll see overall the design is pretty much the same, but we find that in the center here there's another additional antenna that acts as both a receiving and transmitting antenna. And that's for a remote start, a push button start system. Chrysler likes to call this their keyless go for this particular key. It's called a keyless go system. So let's talk about some of those systems, or let's talk about what we're going to call our standard immobilizer system throughout the rest of the class. When I reference something as our standard immobilizer system, this is what we're going to be talking about. Talking about a...
Can I throw a question out to you just real quick?
Please.
Security systems in general were somewhat complex before, but lately they've become extremely complex. Is there a year break that you can identify that these systems have integrated more features to make them more secure?
Not a solid number, but around 2011 and up, they start to really get integrated into many more modules. By 13, nearly everything involved 2-3 modules or more. And then some of the systems kept pretty simple. Like this standard one we're going to talk about, there's all three of the major manufacturers of the domestic variety anyway, still use this system on a lot of vehicles, but it's usually a work vehicle, a cargo van, a work truck, something like that. Not many of their flagship vehicles. Like even something as inexpensive as like a Chevrolet Cruze, one of the lowest cost vehicles you can purchase from GM, has a push button start system now. When it's a 18, 19, or 20, they all have it. So once you get to a push button start system, the amount of modules involved doubles or triples.
Okay, thanks for that perspective, Keith.
Yeah, absolutely. So we start our system with just a key. The key houses a transponder that communicates with the antenna ring. And that antenna ring listens for the transponder ID and transmits it to a module. That module then takes that information and transmits it to the engine control module. Engine control module usually will challenge that response, and if the two calculations are correct for each other, then it'll release the immobilizer system and allow it to start. So we're going to call that our standard immobilizer system. So when we deviate from that, we're going to kind of break apart and talk about the differences in the systems that are like this, and then some of the diagnosis of this system. So we'll start with Ford, since we've kind of already led into talking a lot about Ford. And I'll use Ford as one of the examples I use the most to teach on, because there's so much service information about them. It makes it a little simpler to learn. And then once you've kind of got the basics down of how all this works, it becomes a lot easier to integrate other vehicle systems in there, because under most circumstances, Ford, GM, and Chrysler usually didn't invent the Immobilizer system, but they integrated some other companies' different systems together into theirs. So a lot of the techniques used on how they operate are shared amongst most of the manufacturers. So I like to break Ford down into 3 basic systems. PATS, passive anti-theft, it's a name that Ford uses, 1, 2, and 3. These are very approximate ear brakes. So please just be aware they have a lot to do with the different model. You can have a Ford truck that has the same Immobilizer system in 2020 as it did in 2004. Just kind of depends what trim level you've got and what exact vehicle. But PATS 1s were predominantly available from 95 to 99. PATS 2 were operating around 99 to today, but 2013 there was a clear break off to the new PATS 3 system. And we'll talk about that. And I don't believe it's called PATS 3. I'm calling it PATS 3 because they were called PATS 1, PATS 2, and then there's this new system. So it will be difficult to find in service information if you're looking for a PATS 3 system. So PATS 1 and 2 systems required a 10-minute waiting period to access. So if you had a capable scan tool or the factory scan tool, you could access the PATS functions. It would make you wait a 10-minute countdown usually. And then you could perform like the parameter reset to add a new module in, or just simply adding a key or deleting a key, or any of the other Immobilizer functions. Now in 2013, in that PATS 3 system that we're naming, Ford started that in 2013 with the Ford Fusion and the MKZ. Now again, this isn't every Fusion and every MKZ. Oh, I think it is every MKZ, but I don't believe it's every Fusion. I know it's not every Fusion. I worked on a 14 or 15 Fusion not too long ago that was just a key turn, had an actual lock cylinder, and it did not require a locksmith identification to access those. And that's the difference in these systems, is they don't require a 10-minute wait to access. They require you to log in with your locksmith identification information directly in the scan tool. And that's the other challenge. I don't believe there are any aftermarket scan tools that allow this kind of function to happen with logging in with your LSID. And then as you can see, 2015, they've added the F-150, the Edge, the Mustang. And again, it's not every F-150. These were usually just the push-button start cars. So if you see a 13 Fusion as push-button start, there's a very good chance, 99% likelihood, that it's a LSID car that requires that locksmith identification to do any of these functions. You see a 15 Ford with a mechanical lock cylinder and a key, about 99% chance that it does not require locksmith identification, that it only requires a 10-minute wait. So again, I would make sure you read your service information. That's really big. I don't know how many times I can tell you to read the service information and understand what you're about to do and make sure you're tooled to do it. And we'll get into later some possibilities, some probably in the Q&A part where we talk about why you wouldn't want to just go ham and start pushing some Immobilizer buttons and find out what happens. And within those designs, there are different architectures. Like in the PATS 2 system, you can have one that the PATS module communicates directly with the PCM, or you could have one that the PATS module communicates with the cluster, then it talks to the PCM. So there are a couple different designs. You just really need to read the service information. If one of you guys, moderators, could put these links in the chat, please.
Already done, Keith.
Awesome. Thank you. So Ford has these 2 charts. I urge you guys to please copy those off the chat, paste them into a file and save them and take a look at them after the class. You'll be greatly surprised at how much information Ford will give you. These are job aids that are right on Ford's website, available for free. Go to motorcraftservice.com and poke around on the free resources tab. There is a lot of information. So some of the most common faults I see with Fords and all Immobilizer systems that are, our standard Immobilizer system type are bad keys and failed PATS modules or antenna rings. Now, I run into a lot of antenna rings that are failed because someone's tried to steal the vehicle, or someone's tried modifying the vehicle and adding something in, or somebody More recently, somebody took it off because they thought somebody put it on there to track them. So you would really be surprised the things that I get asked to do. So when testing bad keys, this is something that some tooling would be required and would really, really help you out. There are things such as the VVDI key tool or mini key tool also is what it's called. I don't believe the original one's available anymore. Tango is another key tool. I believe the Autel line of tools now makes some tools that actually read transponders. So you can put a key inside of this little plastic cup, press a button, it'll read the transponder and tell you if it read or not, and what the serial number and the encryption bitting is of the key, the transponder type, and there are just hundreds of different transponder types out there. So being able to do that would tell you if the key communicates and is good or bad. That's one great test. Someone also brought up in Monday's class that there's a tool that can be purchased inexpensively that's just a actual ring of wire with an LED on either end, and that will be energized by the coil itself. So if the coil's working and trying to power up a transponder, that would light up that little LED light. And I think if we could probably try to find that too, that link, if you don't already.
I'm putting the link up for it right now.
Awesome. Thank you, Rich.
No problem.
So those are some pretty inexpensive. That's an inexpensive tool. I think he said he found it for $6 or $7.
It's on Amazon for $6.
Yeah. So it's fantastic. That's a great way to check that PATS module to at least see if it's attempting to communicate with the key. You know, and if you don't have any communication with the key or any ability for that transponder to be energized, you could start looking at powers and grounds on those PATS modules or the antenna rings and testing them. We're going to talk about here next. And it's fairly simple. It does require an oscilloscope usually to most accurately test it, but absolutely they can be checked. And then if you do find a intermittently bad key, it's usually because it's physically damaged. I can tell you that my experience has yielded that as the most common result. So if we're going to test an antenna ring on a Ford specifically, they're a really simple design. They usually have some kind of battery positive. I wrote here constant, but I think most of them are switched, honestly. They do have a constant ground. Then there's a TX and RX communication circuit to some other module. So Ford is broken into, and the PATS 1 and 2 systems are broken into two types, a 40-bit and an 80-bit. They now have a 128-bit Immobilizer system as well that's derived from a European system, but it operates on very similar principles. The bitting of the key, or this is different than like the key bitting. The 40, 80, and 120-bit is the encryption type, so it's the type of chip that it uses. But the type of chip between 40 and 80-bit changes the communication structure for the PATS module. So on the 40-bit module, there's a B plus to the PCM on the TX line that is provided by the PATS module. So that PATS module is actually providing a B plus out to the PCM on the TX line. The PCM, when the key is signaled on, will actually pull that 12-volt signal to ground, and that commands the PATS module to power up the transponder and read the data off the key. So when it does that, the transponder will receive the data, and then it'll pull the 12-volt signal down on the RX line. Now, the RX line is actually receiving 12 volts from the PCM. So the TX line and RX line both are resting at 12 volts, but either one of them is provided the voltage by a different module. So there's a testing clue for you as well. If you go up to this system and you have B plus to the PATS module and you have a good ground, but you have no B plus on the TX line ever, your PATS module has failed. Conversely, with the PCM, that'd be a much more difficult diagnosis. Of course, you would need to go trace down, make sure the PCM has a lot more powers and grounds to check. But again, knowing where that voltage comes from, which module it comes from, it can aid you in diagnosing what is the concern. Because before, if you didn't have this information, you'd be really hard pressed to determine if it was the PATS module or the PCM was failed. On an 80-bit system, the voltages usually work reverse to that. So the RX line is receiving the 12 volts from the PATS module, and the TX line is receiving the 12 volts from the PCM. And again, this is a usually situation. Yes, sir.
Sorry to interrupt. I was wondering if you could elaborate before we get into the wiring diagrams and the functionality, the circuitry, I should say, of these systems. Could you elaborate on testing those antenna rings with an oscilloscope?
Right. So when when you're looking at them on a voltmeter, you've got to understand your tooling here. Your voltmeter will usually read the voltage and create an average to display to you, and that average is whatever is happening over a 250 millisecond transaction period. An oscilloscope, you can see as quick as the resolution, frame rate, whatever you set it at on the refresh rate, and as quick as your eyes can see. The issue is that most of these pull down signals happen in a 5 to 50 millisecond window. So if that happens, and then you average, if it's 12 volts, and pulled down for 1 millisecond, pulled down for 2 milliseconds, pulled down for another 20, then pulled down for one more, so on and so forth, 5 or 6 times to create a packet of data. The average time that voltage has changed is maybe 40 or 50 milliseconds. Well, over 250 milliseconds, your voltmeter might read that as 1 or 2 volts, or it may just completely ignore it. So it's very possible you completely miss whatever is happening on those communication lines without an oscilloscope. At least with an oscilloscope, you can see the voltage over time, so you can see an image of the transaction of data there. Is that a good explanation, Randy?
You bet, Keith. Thanks.
All right, no problem. So real quick, let's look at a wiring diagram of this standard PAS module. You can see it's just got a, get my mouse to move here. There's a hot and starter run power. There's a constant ground. There's your TX and RX. Pretty simple circuit. Not nearly as scary now that we know how it works. And then here is another example. And you can see rather than going, if we go back up that last one, you'll notice the communication lines go straight to the powertrain control. In this particular older system, it has the same setup, hot and starter run, a constant ground. I cut it off, but I promise it's supposed to be a constant. And then our TX and RX lines go to the instrument cluster on this system. So again, just a different variation of the same system. The principles of operation are all the same. The module it communicates with is different. That's really it. So we're going to move to General Motors systems next, and we're going to kind of elaborate on the systems. Again, that's not all of Ford systems, but we're going to use different manufacturers to kind of elaborate some of the different systems that are out there.
Okay.
So with General Motors, we talked about before the VATS system. The pass key 1 and 2 were the old system with the resistor key that operated somewhere between 86 to 05. The pass lock system, which had 2 generations, pass lock 1 and pass lock 2, operated in 95 to 2009. The difference of those 2 systems is where the actual pass lock sensor came from. The pass lock sensor was either in the key or in the lock cylinder housing assembly. And that's what differentiates the pass lock 1 and 2 system. Then the pass key 3 system, which operated about 05 all the way up to present, is our pretty standard immobilizer system we talked about. Now, pass lock 1 and 2 and the pass key 3 system are both considered our standard immobilizer system, but the principles of operation and modules required were completely different. They used a totally different architecture. Pass lock 1 and 2 had its own little separate module that was specifically only for the immobilizer system. And the pass key 3 usually has the data being read directly to the body control, and then from that point communicating with the engine control. So like our drawn out image that we shown earlier. Now GM, that's kind of all we're really going to cover on that on GM. There's not much differences in those. Again, just relying on your scan data for diagrams, but the components have very similar design. Testing is very similar. You just kind of got to read what each one is designed to do in order to diagnose them. But we'll use GM to introduce push button start system. So GM's particular system is called PEPS, or passive entry, passive start. And in about 2010s when they first introduced it, I believe one of the first models was like the Camaros and the Cadillac SRX, that kind of stuff. And again, those dates are super approximate because it really depends upon the model. So the components of the GM Pep system. There is a base station module that is designed to really be an immobilizer module on its own. There's a start-stop switch, the intelligent key system or smart key, whatever you want to call it. There are some low-frequency antennas in and outside the car, along with doorknob switches to initiate a customer request. So a driver request, someone walks up the door, presses the button on the door, says, "Hey, I want in," and then it starts looking for the key. There's single pass-through switches in the doorknobs. There are the steering column lock is only offered. It says offered by a cooperating manufacturer. That module is usually only found in vehicles that are branded as a General Motors product, but are usually built by another company, like an Opel product or a Daewoo product that's branded as a General Motors car, like a Spark or a Sonic or something. So just, not every one of these systems has a steering column lock, but the ones that do are usually built by another manufacturer. So service information is kind of difficult to find on them. But what's really interesting is how, for lack of a better term, convoluted this system is in its communication between everything. So I'm going to break down the steps in starting or not starting a car using this PEP system, just to give you an idea of how many different modules are integrated into this system. So like we talked about, there's a bunch of antennas in and outside the vehicle to detect its location, so keep that in mind. So when the ignition switch is pressed, the interior antenna is a challenge to the key. The key receives the challenge and sends its response as a radio frequency message to the remote control door lock receiver. Then the BCM gets the message through the remote control door lock receiver. So we've already gone from ignition switch being pressed, keys are talking to the antennas, the messages are sent to the remote control door lock. The remote control door lock turns around and sends it to the BCM. The BCM compares that value to what it has in its memory. And then the car just starts, right? Oh no, we're not even halfway through. The BCM monitors various control modules to determine if the stored environmental identifiers match. Multiple modules in late model GMs have what's called an environmental identifier stored in them from the very first time they're programmed to a vehicle new, and that environmental identifier is synonymous with the one vehicle. And even during a programming event, that identifier does not change. So that is why you'll find a lot of warnings about not using used modules from other vehicles in late model GMs. And that's because you can easily set a theft event by using a used HVAC module or SRS module or instrument cluster, because those are all modules that will house an environmental identifier. Now, if both the environmental identifier and the value received from the key match, the BCM sends a pre-release password over serial data to the ECM. If they're incorrect, the BCM disables fuel immediately. So the ECM has received a pre-release password from the BCM, and it challenges that password. So that challenge is sent back to the BCM over the serial data. Now the ECM and the BCM both have received a challenge now from each other, so they're going to perform a calculation on that challenge. If the challenge of the calculation is correct between both of them, it allows it to start. So that's a lot of modules. So what do we have here? We have the low frequency antennas, the key, the remote control door lock receiver, the body control module, the engine control module, and every other module that has an environmental identifier, which to my knowledge are engine control, body control, instrument panel cluster, HVAC, and the SRS module. Those are the 5 that I know on almost every car that's a Global A has, or the late model architecture, without going too far into that, has an environmental identifier. So that's 6-7 modules that are required to start this car. Everyone think it's going to be really easy to figure that out? Would that be a lot of testing? This is where you would heavily rely upon scan data and your scan tool. So maybe it'd be a good time to step away from your scope for 5 minutes. I'm a scope guy, don't get me wrong. I like scoping all the things, but you also really have to pay attention to your scan data and reading codes and looking at each module's live data and seeing what's going on. Seeing the codes in these things. Seeing there's data PIDs for each one of these modules if it's received its correct data. So you can really follow this chain of command all the way through your scan data to determine what's at fault. Now, when we talk about adding keys to this system, how do we program keys? Well, Ford had the 10-minute wait, and then they had where you have to use the LSID that we talked about earlier, and we're going to kind of cover that some more later. GM's is really, really different. Usually when you're just adding a key to a system, like you already have an operating key and you'd like to add another one, there are almost no tools required. On systems that have a lock cylinder, the procedure is usually insert the key, turn it to the on position, don't start the car, wait for the immobilizer light to go out, or within 5 seconds usually. Take that key out, take your unprogrammed key, cycle it on, and after 3 to 5 seconds, that key has been added. And that's really about it. On the push-button start cars, it's very similar. It's different locations for each one of them, but you'll usually place your working key in a location, turn the car on, with the push button, turn it off after a few seconds, and then replace the programmed with an unprogrammed one and do the same thing. Usually the push button start cars require 2 working keys to add a third one, but again, it's all dependent upon the make and the model specifically. Now, an AKL or all keys law situation, that usually requires you to perform a programming event, like with a J2534 device and a subscription to SPS on GM's website, just like you're going to replace a module. You'll go in and you'll select Immobilizer learn, and you'll select if you're adding a key or if what the situation is. And that takes about 10 minutes. So that is a 10 to 12 minute countdown after you've initiated that programming event. And then you'll be able to add that. There's also, on a lot of these GMs, a manual option. If you don't have SPS programming, you can just take your unprogrammed key that's cut, cycle it to the on position on the car, wait 10 to 11 minutes when the immobilizer light goes out, cycle the key off, cycle it right back on, again, not starting it, and performing that same procedure 2 additional times for a total of 3 times. After the end of that 3rd time, when you go to cycle the key the 4th time, the immobilizer light should go out after 3 to 5 seconds, indicating that it is programmed. So that's a manual option. Again, it's not available for every single car, but if you read your service information, you may find that that is available. Now, also things like when you replace BCM, PCM, or other theft-related modules, there is immobilizer functions that has to be done. So that's another SPS event, a programming event. And not every time will the 30-minute manual situation work for a replacement module. And what sometimes it does, it has unintended consequences. I've ran into on some GMs, particularly an SSR, I remember, that a BCM was replaced and it was failing to perform the SPS programming through the SPS system. So the customer attempted to do the manual and it would start, but it left a airbag code because the SPS event hadn't been performed correctly. So the airbag initialization was part of this body control system. And because it hadn't been through the immobilizer system correctly, it also wouldn't learn the airbag STM primary key. So without going too far into module programming, it can get convoluted. You need to make sure you follow service information. Service information outlined in this one that the 30-minute manual was not advised. So let's talk about some Chrysler Systems, unless there's any GM stuff we need to cover.
Quiet group here tonight.
Oh yeah, getting all the questions for me then. Get them all ready. So the Chrysler Systems. There are 4 main Chrysler Systems is how I'll break them down. The Sentry Key Immobilizer System, or SKIM, operated from 98 to 2006 era. The Scream system, Sentry Key Remote Entry Module system, which is really just the same as the SKIM, but they add the remote entry or the remote keyless entry functions to the same one module. So the SKIM system had the transponder unit by itself, and then a separate module or part of the body module for doing like keyless entry functions. And then the Scream system added those 2 together. So put them all into one module. And that operated from about 04 to 2014-ish. Service information still calls that Scream module a WCM, a wireless control module. Now, the wireless ignition node system, the 2008 to present, is the most common we find. That's the one with that phobic key that just goes in the dash but doesn't have a metal key. I'm sure you guys are all familiar with that Chrysler style key. That was technically called a wireless ignition node, the unit that key goes into, but it's also referenced as a wireless control module and service information. So it gets really convoluted when you find that between 04 to 2008 and 9, some of these Scream systems, they still called them the same as the later ones. Now, the wireless ignition node systems also had the push button start in them, which was called a keyless go system, but that's separate than the smart start system, which were a push button start car without a WIN module. Those used a radio frequency hub, and I'm going to kind of break down both of those systems for you, so don't get too hung up on it right now. Here's kind of some images of what the SKIM, Scream, and WIN modules look like. Again, the WIN module there on the far right is one we're most commonly found in Chryslers that I work on, at least. I don't work on so many SKIM and Scream cars anymore. The Scream cars that are up to 2013 and 14 are really hard to find, usually not a U.S. market car. So how they're wired gives us a lot of information. On the SKIM cars, there were 4 wires on that SKIM module. Very simple. Had a constant power, a constant ground, a fused power, and then a single PCI bus communication line. So real easy to determine if it was communicating or working. The Sentry Key Immobilizer systems, the screen modules, those had a few more circuits on them, but again, not much different if we look. They had a couple constant B pluses. They had a constant ground, a comm line wire for the TPMS system, a fused ignition wire, and then CAN bus wires. They were on the CAN bus. So again, a pretty simple system to diagnose if you're concerned with it working or not, or if you're able to communicate with the module or not. Now, the WIN modules had appearingly a lot more circuits, but when you break them down, there's not much that's going on that's not out of the ordinary for a immobilizer module, just short of that brake lamp and the BTSI unlock control. That's if it had a steering column lock. Again, usually U.S. market cars don't have steering column locks that are electronic. I don't know what the domestic thing is with that. Most Asian vehicles do, but I guess domestic manufacturers didn't put them on a lot of North American vehicles. But we have, in essence, a constant power, an ignition power, a LIN wire for a TPMS, a constant ground, and CAN wires. That's it. It was a pretty simple design when it comes to determining if it's good or bad and communicating. So how does that WIN module system work? Because that's the system we're going to run into the most, and it's a little different than the others. So when the key is turned on, the WIN module transmits a low frequency signal to the key, the phobic. The WIN module then waits for the low frequency signal response from the phobic key. And then if it's valid, the WIN module will send the valid message to the PCM over the CAN bus. So it makes all the determinations inside the WIN module, and it just tells the engine module, hey, we're good to go. And then the PCM will enable or disable engine operation based on that status message that it receives. So an interesting thing is the default condition for the PCM is invalid key. So if the message doesn't come back from the WIN module, it'll die after 2 seconds of running, which also tells us that if we're ever having an immobilizer concern and it's a crank no start, then it's not really an immobilizer concern because the PCM is prompted to start and run for 2 seconds. And once 2 seconds of being in an invalid key situation, then it shuts off. So if you've got a crank no start or a no crank condition and you believe it to be like an invalid key problem or an unprogrammed key or something, you can bet it's probably not. So all of that information was found in service info. And with that little bit of reading, we've actually helped narrow down so many of our crank no start conditions to being not an immobilizer concern if it doesn't start. Now the push button start vehicles, the keyless go system that still have a WIN module, those, with the exception of the push button part, operate all the same on the back end. So what's different about them is that there's a separate passive entry module. And that passive entry module is wired to a couple antennas that are listening in for the key being in the vehicle. There's also wired to some door switches and liftgate latches and such. But really, that passive entry module is looking for when the push button happens, the WIN module communicates to the passive entry module and says, hey, do we have a good key? And through those CAN lines, it says, yeah, you're good to go. I see the key. And this is the key numbers. And then everything else from that point forward is the same as if we've had the key in the dash and turned it. The smart start systems, which do not have a WIN module, those incorporate a radio frequency hub. There are a lot more parts in the system. So there's the key, and then the KIN, the key ignition node, which is just the push button itself. Radio frequency hub, which to the right has a ton of antennas attached to it as well. You can see in the diagram. The powertrain control module, and then the cluster and the TCM and electronic steering module and the body control and all those other inputs, they all matter. They're all part of the system. This one diagram is the starting system circuit diagram. So you can see it has a little bit to do with everything. So on that system, when you press the KIN button, it sends a request to the radio frequency hub over its own little LIN bus. From that point, the radio frequency hub will request that the keyless ignition node looks for a valid key over low frequency antennas. So the RFH hub detects a valid key if the brake is engaged, then it sends a CAN request to the BCM and challenges the ignition position to start crank. So this is where all this cross module communication happens. And then the BCM sends the command to turn the vehicle to crank. So if conditions are correct to start, the PCM turns on the high side PCM, the starter relay first. So both control sides of the starter relay, the high and the low side, should be pins 85 and 86 of a starter relay. So the high side is powered by the PCM and turns the crank hold signal to true inside the scan data. You'll be able to see that. At that point, the RFH hub changes the ignition position to run if the start type is a tip start. The 5-second time expires, or the engine controller indicates the vehicle is not in park or neutral. So once it's determined it's gone that far past the 5 seconds, it goes to the run position and scan data, and you'll be able to see that. Now, the engine can manually be shut down by the driver by pressing and holding the start-stop button with 5 speeds over 5 miles per hour in any gear. So if you have a concern where you need to shut the engine down and just simply pressing the button isn't going to do it because you're not in park, right? You can't unless you're in park or neutral. You can press and hold the button, and it should shut the car off. So, but if the BCM is still in crank position and the crank holds true, the BCM turns the low side of the BCM starter relay and the engine will start cranking. So again, the high and the low side of the relay are controlled. Neither one of those is a constant power or constant ground. So when you're doing your standard checks and pulling a starter relay and starting to just pin probe things out, if you haven't looked at a wiring diagram yet, you shouldn't be checking for anything. You should build your test plan first. A lot of this should start with looking at scan data.
Hey, Keith.
Yeah.
We have a question from Chip.
Mhm.
Is the 2-second run install only applicable to Chrysler, or can we use that across most other makes and models?
That is usually applicable only to Chrysler wind module systems. The skim and scream systems were a little bit mixed because there are many of those that crank don't start. But if it's got a wind module, if it's got a black plastic key that goes in the dash on a Chrysler, you should get a 2-second start and install if it's a theft problem.
He says, thank you. Perfect.
Yeah, no problem. I'm super hesitant to ever tell any of you guys that this works for every car.
There's always one out there.
Just short of that,
us
most
a
of the
liar.
tires take air is the best thing I can give you for across the board.
I don't even know if you can say that anymore.
Yeah,
Somebody will
most
come up with
of the tires
something.
take air. Most. And then the engine will start and the PCM deactivates the double start override. And then the BCM will deactivate the starter if the engine starts or maximum 10 seconds has been reached for the tip start. So that's one of those where you take the, you press the button and it goes, and it, it's not starting. It's 10 seconds. That's a long time on a starter, if you ask me. So that's again, all these push button start systems, you start reading through all the steps that it goes through and all the checks. There's a lot there. There's a lot of modules. There's a lot of stuff to look at. And it really has to start with taking a page out of Mr. Falco's book here and putting the scope down. Again, I love scopes. I don't know how many times I'd say this. I had a conversation with somebody after I taught this class last, and they're like, man, you're really big on scopes. And I was like, well, yeah, but I'm bigger on scan data first. It's just, so start with scan data. Does it have codes, and does each of the modules that are involved in this system seem happy with the key that's in the car? So I would say that, and I want to reiterate that a couple times. Now on programming Chryslers, and when I say programming, I guess registering, teaching, and keys, doing Immobilizer functions on Chryslers, this is one of the manufacturers that uses PIN codes. So these PIN numbers are stored in the EEPROM of the skim, the scream, the WCM, or the wind module. Now, unlike the keyless go systems and all those, they can be stored in multiple modules. So if it's a wind module car that's a push button start, that PIN number is stored in the passive entry module and in the wind module, and they have to match. So a lot of the guys have found that if you replace a wind module, when you go to click in your scan tool, replace wind module, it'll ask you for a PIN number. And whatever PIN number you type in there now becomes the new PIN number. Ooh, fun trick everyone just learned, right? Do that on a keyless go system and put the PIN number in wrong. You get to go buy another wind module and then still purchase the PIN number to find out what it is, and then make sure it's the same as the passive entry. Otherwise, the push button start function will never work. So that's a very upset customer that push button start no longer works.
Hey, Keith, there used to be a lot, and still are some websites out there that advertise that they'll sell you a PIN number.
Yeah.
Can you comment on that and why it might be a bad idea?
A lot of those are shut down. And then you got to think that you're circumventing a system put in place that works in cooperation with law enforcement. So I would venture to guess that the ramifications of purchasing a PIN number and using it on a car when you're not authorized to could have some legal ramifications. I don't know what they would be. I'm not saying it's ever happened. And then it's a very good chance that since you know they're not operating legally, because there's no one out there that can sell you a PIN number for Chrysler except for Chrysler through the moparkeys.com website that's directly through Chrysler that requires a locksmith identification through NASTF. So if they're the only ones that can get you one and you pay to receive one from somebody else and it's wrong, you really don't have any ramifications getting your money back. And then, what if it's the right one, but it's one of these next ones we're talking about, this late model wind module smart start systems with a rolling code. These rolling codes are a scan tool calculation that's authenticated through a network. So very recently, I think there was 3 or 4 Facebook posts I responded to try to help some people out with. They were performing some kind of module replacement function, and they were getting an error 702. VIN is present in the accessory table, and that is what the error said. So it's really obvious, right, what that problem is? That you got the 4-digit PIN number from the dealer? Isn't that really obvious? No, it's not, right? So everyone was pretty confused what error 702, VIN is present in the accessory table means. So I don't know why it means that, but it does mean that the PIN number you just used is one that your buddy at the dealer gave you, and that will not work. So the dealer uses Dealer Connect as their authentication on the back end of the network. So when you purchase a Chrysler factory scan tool or you start using the YTech subscription through a JBox to try to have a factory level tool for Chrysler, when you go to put in a PIN number to perform a Immobilizer function, that PIN number is calculated and the calculation for authentication is done on the back end through the Tech Authority server, because that's what we log in through the aftermarket is our Tech Authority subscription. One of the many subscriptions required to mess with Chrysler. And we can talk about that later if somebody asks about it. But the dealers use Dealer Connect, and it's a different calculation. So the PIN number for the dealer is different than the PIN number for you. So if you are working on a rolling code Chrysler, anything with a RFH hub, or pretty much anything 18 up Chrysler, the PIN number that the dealer gives you is not going to work. You are going to have to get an LSID or take the car to the dealer, one of the two. Then also you'll find some of your aftermarket scan tools will pull a PIN number and give it to you on these rolling code ones, and they'll give you a 5-digit number. That number will not function to perform many Immobilizer functions outside of what that scan tool offers. So don't think you can pull that 5-digit number and then do a BCM replaced function with YTech or something, or with another tool. That 5-digit number will allow you probably a key programming event, and that's about it. So where do we get these PIN codes that we're talking about? These elusive codes that are so scary, right? The only legitimate source to get them is through NASTF. To get a locksmith identification number to become VSP, a vehicle security professional, there are a couple things outlined on NASTF's website. It is different depending upon where you live. But for the most part, the overall requirements are to have a certain level of insurance, to have a certain level of, they have to pass a background check, then there's a fee associated with it, and then a wait time. And then there is a little line in there that says that if your state requires a locksmith license for like just locksmithing in your state requires a license, then you'll have to have that as well. And that can pose a problem because in like the state of Oklahoma where I live, to get a locksmith license, you actually have to work as an apprentice for 2 years under a licensed locksmith manager. So there can be quite a long wait period if you're trying to get your LSID, depending upon where you live.
Keith, I have that website up if you want to take a look at it. I can
Please.
share that. And there we go. I actually pressed the share button this time.
Yeah.
So this is the NASTF website, and like we don't need more acronyms. It's not LSID anymore. It's VSP, or Vehicle Security Professional. The other acronym you're going to see on this is SDRM 2.0, and that's the Secure Data Release Model. This is where you want to go to get more information on how to apply, how to get your VSP number. And I would encourage everybody whoever picks up a scan tool, whether you cut keys or not, to get this, because there are some functions. I'm thinking of Ford in particular. Maybe Keith can elaborate on that. There are some functions on some vehicles that require that because that particular component has something to do with the operation of the security system. I'm thinking of a parameter reset on Ford, among other things.
Yeah, and then as you get into like a 18 model Expedition EcoSport Aviator vehicles that are on a different scan tool now, the FDRS scan tool, separate than Ford's IDS. The new generation of vehicles will all start being on this new scan tool of theirs that's web-based. A lot of functions just to do bidirectional controls and do things require LSID access or VSP access. Sorry. There was a recent issue that was dealt with that was kind of a pain point for some people. They were trying to perform a restraint control module replacement, and that required you to have a VSP number on 18 and up Expeditions, because apparently the restraint control module has something to do with the Immobilizer system. So in order to replace that, you must have your VSP number.
Yeah, it's crazy, isn't it?
It's becoming more and more integrated, theft and Immobilizer into every module in there. So you will need a VSP eventually. If you have not already ran into a situation that's prevented you from fixing a car, you will at some point in your career.
Yeah, so shop early, get your VSP.
Mm-hmm.
So definitely worth the effort. As long as I've got the browser up, this is Ford motorcraftservice.com, and this is the Pat's Job Aid that Keith alluded to. And there are two of them. The links are in chat. And I'm here to tell you, this will tell you almost everything you need to know to service a PAT system. It's just a phenomenal piece of information from our friends at Ford.
Yeah, it's absolutely wonderful they gave us that info.
Yeah. Kind of one-stop shopping.
Yeah.
So, all right, well, let's entertain some questions from the crowd.
Yeah.
If you have any questions, guys, put them up in Q&A or put them up in chat.
While we're waiting for questions, let me share something real quick. Randy, you stole some of my fire. I was going to share that the Ford Pats thing here, because I had both of them up, the older one and the new one. But yeah, if you guys are going to do a Ford, you should go there first, because there's just a wealth of information. The other thing I wanted to share, where the heck did it go? Sorry, my chat is hiding all this. I put the link up in chat for that little test coil.
Yeah.
There it is. Put it around a system that's working. The LED should light up. And if it isn't, then obviously the LED doesn't light up. And it's a whopping $6. So that's an easy thing to find. And Keith had warned about Global A cars, and I put the link up there on AC Delco. If you go to Diagnostic Scan Tool, you will get a chart of Global A cars. GDS2 supported vehicles are Global A cars. If just be careful with those vehicles. So all that information is available for free to you. So
yeah. The reason we say be careful is those are the vehicles that you want to be careful with putting a used module.
Yes.
Can not only that module not work, but it can damage other modules too.
Yeah.
It gets to be a really expensive day.
It gets ugly quick.
Yeah.
So all those links are in chat. If anybody needs, we can put them up again. But
Robert mentioned that he ordered a test coil, and it's back ordered about 2 weeks. So
wow.
Okay. Thanks, COVID.
Yeah, really. And George asked what we think about our particular scan tool. George, we'd be happy to have that conversation offline. We're not going to promote tools here. CTI never has. But my email will be in your follow-up if you'd like to chat about tools in general, not necessarily a specific tool. So since we have kind of a quiet audience tonight, I'm going to throw down the gauntlet and put you guys on the spot.
Gotta go.
Challenge.
What? I'm losing internet. I can't hear you.
I'm going to challenge you to telling us your favorite vehicle security problem that you've run into, and I've got one to throw in the pot too. So
I think every time I've found my favorite one or challenging one is one that I learned something about a system, usually the hard way. Known for a long time that most Fords require 2 keys to do programming. You will find out the hard way at some point if you don't listen carefully that GM has the same issue. You do have to have 2 keys when you replace some modules on late model GMs. And I found out the hard way on an 18 Yukon.
Ooh. Tell us your favorite trick on old Pat's keys, though.
Oh yeah. So when you need 2 keys, what's happening is the module that is the Immobilizer module is waiting to see 2 unique serial numbers programmed one after the other after a parameter reset. So when you do a parameter reset in the instructions, it'll tell you to cycle 2 keys when you're done. If you don't, the vehicle will not crank, it will not start, and you will have a code that says minimum number of keys not programmed. So if you're early in your career like me and you end up replacing a PCM and didn't read the instructions because you're young and you don't know what you're doing and you've only replaced a couple modules ever, you find out that, hey, I have to have 2 keys to do this. So there are a couple things to watch out for. One is cloned keys. So if you get your 2 keys from your customer and one of them says Ford and one of them doesn't, it's very possible that second one is cloned from the first one. So you do not have 2 keys. The module will only see 1 serial number twice, so it'll immediately throw an error. So a couple things you can do is you can get another key of that era of Ford that's the correct either 40 or 80-bit persuasion. You can do this 2 ways. You can pull the clamshell and drop the lock cylinder, or not the lock cylinder, drop the PATS module down, and then you put your cut key in the lock cylinder. You take your other key to the truck that's in the bay next to it and hold it in the coil location. Turn the key on. Wait the 5 seconds, turn it off, then hold the PATS module back up and then put it around the actual key that's cut for the vehicle and cycle it on. It's now seen 2 serial numbers go through that coil, and the car will start and run, and you'll just have one program to it. The other key will be programmed to it as well, but it's not cut, so it's not going to go in the lock cylinder. It's not going to be a problem. The other option you have without taking anything apart would be to cycle the first key that's cut and programmed cut for the car. Then when you take it out, cover the head in an aluminum foil so the transponder cannot be read, and then take that second key and hold it up next to it as you turn it. You'll find a lot of frustration in that method because the orientation of the transponder is important. So you may have to cycle it a bunch of times, may have to do this process a couple times. So it can be frustrating. But there is a little tip or trick to get around the 2 keys cut to the vehicle thing.
Yes,
Well,
Jeff,
you got something from the Euro world for us there, Rich?
Me?
Yeah.
Luckily my Euro world experience is Mercedes at the dealer. And
so order one in by VIN and it comes in and it works.
Yeah, order one. It comes from, I think it was Fort Collins, Texas, and we're done. So luckily, if I've had a security system kick my butt, I'd probably be showing my age by talking about some of those resistor keys.
Yeah.
I will say, for guys out there that are thinking about getting into keys and security systems, one of the toughest things is the little idiosyncrasies to these cars. You'll find some GMs that the security relearn will only work with a Tech 2 or only work with GDS, and sometimes that service information isn't so straightforward and clear, and you're like, man, this is kicking my butt. Why isn't this going through? And you find out that scan tool or that technique doesn't work for that one particular car. So you really got to pay attention to
section of cars.
Yeah.
05 to 08 Buicks and Pontiacs.
Yeah, there's just some weird oddballs out there.
I mean, I could talk at nauseum about all the little goofy things.
Yep.
When you talked about Mercedes-Benz, it made me think of the Crossfire.
Oh,
so the Crossfire is the Chrysler Crossfire.
It's
Mercedes-Benz Yeah, 320 or something. Yeah, it's rebadged, basically rebranded, kind of. So Mercedes keys are the slots that are available for keys in the modules are filled when the car is manufactured. A couple keys go with the car owner, and the rest of the keys sit in a warehouse. Well, the keys for the Crossfire all sit in a warehouse in Germany that burned down about 5 years ago. So if you need keys for a Crossfire, you're SLK'd. You can come up with your own acronym on that one.
Toggle switch on the dash isn't going to cut it.
Nope.
No, that's not going to
Nope.
work. And Jeff brings up a good point. I tell shops 2 Ford keys, and they go to the locksmith and have 1 clone. It's
Yeah.
every customer that I've ever said, "Hey, I need 2 keys," they're handing me one with a Home Depot receipt still hanging off of it.
Yeah, just got a brand new one.
Yep, not going to work. Not going to work.
Yeah.
I used to have a couple patch keys on my key ring, and I didn't own a Ford.
Yep. Yeah, and that is why I got into keys. I bought my first key cutting machine because I'm doing mobile programming, and I run into Ford modules all day long. I'm like, well, let me just cut some Ford keys. And then you go, wait a minute, I have all the factory tools for all the other ones. Why don't I just carry all those keys? And then you go, wait a minute, now this one key cutter doesn't do high security or doesn't do Tibby keys for Ford, and then it snowballs. And then the next thing you know, you find out there's good profit and margin on keys. So, yeah.
Don't give away any locksmith
industry
secrets.
thanks you, Keith. Yeah. Okay, I got one for you. We're going to call this "Don't Take the Blinders Off." Had a older Grand Am come into my shop when I had a shop. Yep, it's a Grand Am. I'm the old guy. And it had pass lock, and it came from another shop that had put 2 pass lock sensors in it, an instrument cluster, because if memory serves, that's where the voltage comes from that's the module in charge. So that's where the signal voltage comes from. And it had a couple of keys just for good measure. And for all intents and purposes, it had an intermittent no start that looked for the world like a security issue. In fact, on the scan tool, it said that pass lock was active. And so that's why they went after it, and that's kind of why I went after it. But I was looking at signal voltage and also source voltage and ground on the pass lock sensor with a scope. Now that vehicle, when you started it up, it would do a self-test on the AC clutch circuit to make sure the AC clutch circuit was working. And the only reason I found this is that I was looking at the scope and listening at the same time, because I saw a drop in system voltage when the clutch came on.
Mm-hmm.
And as it turned out, I also saw a little spike. As it turned out, the clutch was partially shorted, drew a ton of current. Instead of the usual 4 amps, it was drawing like 10 or 12. And then when it released, saw this huge spike.
Back EMF.
Because the diode was gone.
Mm-hmm.
And that fooled the pass lock system into activating and not starting that vehicle. So that's why I say don't take the blinders off. Use all your senses.
Yeah.
Absolutely.
I'm a taste guy. I lick all the keys first.
I'm glad you're in Oklahoma.
Okay. Well, I think that about wraps us up, guys. Thanks so much for all your contributions, and thanks to our audience. Let me share one more thing. Thank you, Jeff. Not forgetting you, buddy. Let me share one more thing for you, and we'll call it a night. And I'll hit share this time. Okay. So, where it says enroll for future virtual classroom events, go to ctionline.com. You can still go to CTI Online, but don't search training and virtual classroom. You can search that for recordings if you'd like, but we'll have another portal to go into that. Remember that we are launching our full-blown CTI courses with all your favorite guys in the upcoming weeks. And next week, in honor of ATE out in Seattle, we're going dark on virtual classrooms. So you'll see a lot of CTI instructors on that event. That event is on CTI Online. If you want to look it up, I would encourage you to enroll in that and watch some of the classes. We've got some really heavy hitters out there at ATE. So thanks to our technical training manager, Jerry Barson, he's heavily involved in getting that up and running. So,
yeah, there's some cool classes I'm gonna check out.
Yep, it's pretty awesome, and I get to moderate Adam Robertson. So hang on. All right,
Keep your seatbelt
everybody.
on.
Yeah, really. Everybody out there, stay safe. We love to have you here. We've just had a ball doing this and really look forward to our next chapter on virtual classroom. So thanks from all of us. You guys stay safe.